What is the most used man-made material on Earth? You guessed right, it's concrete. Look around, it's everywhere. Sidewalks, driveways, foundations, floor you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic Podcast. And today I have Dr. John Belkowitz with Intelligent Concrete. The Tyler Lay called you the Concrete Superman, I believe.
Concrete superhero.
But you also, superhero. And then you host a coffee talk on LinkedIn that's pretty popular with us concrete nerds. Enjoy that.
Thank you.
And you're a consultant in our awesome industry. And what else did I miss, John? Tell us a little bit about yourself.
You know, I've been playing with concrete, and I said this before since I had a full head of hair, but I started early in the industry when I was 14 years old. I had a girlfriend whose dad gave me a job because I was just a bad kid. God bless my parents, my mother. God bless my mother for dealing with me. And I tell you, concrete, and Seth, I'm not going to lie, I'm not a great concrete finisher. I like to pretend I'm a good concrete finisher, but once somebody sees me on a screed, they know the truth. But concrete, I don't get it, man. Like, I really don't understand how and why I fell in love with it. And it is a love, it is a passion, it is a hobby, but it got me out of trouble, man. Like, concrete doesn't lie to you. Oh, man, I'm about to get deep. Uh-oh. Concrete doesn't lie to you. You put too much water, it'll tell you exactly how it feels. Not enough water, likewise. You could spend your entire freaking life learning about concrete. Tyler Lay has proved that to us. Tyler Lay has spent the majority of his life not just contracting with concrete, but also studying concrete. And he has helped us understand the many molecular kinetics of cement hydration. And even with all that he has learned to teach us, and I include you, he'll spend the rest of his life guessing what is happening in that beautiful hydrated cementitious matrix. And that's what I love about it. Spend your entire life learning about it, and there's always more to learn. It's like something out of a fantasy novel. It doesn't seem real that we have been doing what we have been doing with concrete, with cement specifically, and it's all an educated guess. I flipping love that, man.
Yeah. Yeah, no, your recommendation of that book, The Magic Powder by Hadley, I just finished that last night. I didn't plan on it just finishing the book right before we talked, but I did finish it last night.
Good for you.
And yeah, man, that's like the cement Bible, I think. The way that guy writes it.
The way he writes about cement, nobody writes like that anymore. Like,
no.
And, there's another great book to read, and there's only one chapter out of that book that I recommend. It's a tough book to find. Whitney and I went on a weekend getaway to New Hope, Pennsylvania. They have a lot of great rare bookstores. And the book was called The University of Knowledge, and it was published in 1947. And, this is when we really started using concrete on the East Coast, and it started traveling west. And there's something, the author says something to the effect like, and the ribbons of concrete tapestry this great nation. Like, it's just such a magical way of putting civil engineering on a pedestal. So, yeah.
Yeah.
Great books.
Yeah, that Yeah, same era of the magic powder, right? That the 40s. Right. Yeah, folks don't write like that anymore.
I
about anything, much less concrete.
I think there are a couple of good authors, and if I can recommend some authors for you, if that's all right.
Oh, yeah.
John Belkowitz, the guy writes like Mark Twain, William Shakespeare.
I think I know that guy.
I think you know that guy. Brilliant dude. No. Kim Curtis from Georgia Tech. Her paper on soft X-ray gel, ASR gel microscopy. One of her students, Jamal Jayalapan, he wrote a paper on the size effect of nano-TiO2 in cement hydration. There's a guy, Bjorn Bjornstrom, who wrote a paper in 2003 and then a sister paper in 2004 on nanosilica in cement hydration, this effect that we have called accelerated cement dissolution. And then two more papers. Oh, no, three more papers. Sorry. Stephen and Land wrote a paper on nanosilica back in 2012 on something that they called calcium silicate hydrate seeding effect. The second to last one is Brian Green's paper from 98 on ultrafine amorphous colloidal silica for a rock matching grout. And then there's this paper by what is his name, Whitney? The Glassy Nature of Water. And it talks about, and I can't remember, I want to say Professor Ohm is on that paper, and this is from MIT, but it talks about getting water or analyzing water within the fractal network of the hydrated cement matrix, but specifically looking at water in a confined space so that you restrict its molecular movement, and in doing so, it changes from having a bulk state, being able to freeze, thaw, vaporize, to having a glassy state, meaning it has strength to it. Oh, what a great paper. Great paper.
Man, and people think it's just water, cement, sand, and some rock. You mix it together and you get just concrete.
But it is that. My mentor, the guy who wrote that ultrafine amorphous paper, Brian Green, when bless him for paying for the majority of my PhD. I really owe a lot to him. I remember when I started my PhD, he had me over the house for dinner. I think I called Whitney right after this. I was so nervous. This is like the first time I'm like really hanging out with him. It's just me and him. And he's like, listen, man, I know this technology is cool and all, but if it ain't gray concrete coming down the chute, ain't nobody ever going to use it. And that stuck with me up until this day. I mean, I still use that. When we speak to customers and we interview them about, trying out or evaluating or, being that poster boy for their technology, one of the things that we have to make sure of that this is a real technology, and that it's not just a very expensive research endeavor, which is fun.
Right.
And I don't mind doing those, but we don't do research, and that's the difference again between Tyler and I. Tyler does oftentimes research for the sake of research, and most academic folks do. We do research for the sake of commerce. Our research has to have a return on investment. So, yeah.
Yeah. Yep, it's got to have practicality to it, right? It's got to,
Absolutely.
So, yeah, you got to know what the customer wants at the end and what you want. We want the concrete to do, and then sounds like you figured that out for us, so you can do all that. Figuring out how much of each component of concrete we need to serve a purpose.
And, Tyler said that I'm a concrete superhero, but you know what, man? I would include all of us who are in this occupation as concrete superheroes. I mean, when you wake up in the morning, I don't know if you jump out of bed and say, Sato light, or concrete, or cement, or construction. I wake up and I jump out of bed, and I've got 2 books sitting on my nightstand. One is for better business, because I'm always looking to be a better business person. And the second thing is a concrete book, because I'm always looking to educate myself in concrete. And I think you're that type of person too, and so is Matt. All of us are, trying to figure out how we can make concrete better, stronger, and last longer. And because of that, just like Superman or Bruce Wayne or Batman, we're all concrete superheroes.
Yeah. Yeah, maybe.
Some of us are villains.
Yeah, I feel like I'm more of a defender of concrete, but like you. But anyways, let's get to what we want to beat up on today.
Sure.
Let's talk about carbon neutrality and carbon negative. All that good stuff. We're trying to define it. So I've had multiple guests on the show, and we've our friend Rich, our friend Tyler, a couple other people. I think we've briefly discussed it, but let's discuss that.
Sure.
Kind of like from where you sit, and so how do we define this concrete carbon neutral thing?
I've been reading papers since 4:45 this morning, and you've been using Google Scholar. I don't know if you're a fan of Google Scholar. Yeah, gotta use it. So when you open up Google Scholar, on the top bar you have a search toolbar, and you can just type your keywords into it, and you can do an advanced search where they allow you to the date blah blah blah, and you click search, that little magnifying glass. And it has all the papers, the names of them, with the link right in the center. On the left, it has some stuff that you can make choices of. And on the right, it has these separate links that are much, much shorter. And those links will take you to a free version of the paper. Right? Score. Now, not all papers have a free version, because most of these publications, cement and concrete research, innovations in civil engineering, they charge you. They charge you $30, $40 for an issue or a monthly fee. So I've been looking at all the free stuff this morning, and a bunch of papers from MIT, from Michigan Tech or Middle Tennessee State University, Australia. So many papers from Australia, Monash University, some of the unis out there, or other unis out there, and then some universities from Japan. And man, I've got definitions all over the board. So I wouldn't recommend trying to do it that way. What I did do is I said, okay, now that I've wasted, I don't know about wasted, but now I've spent all this time, I'm going to go the organization route. And I went ACI, and then I went Portland Cement Association. I'm a huge, huge fan of ACI. I'm not a current fan of the latest president's notes on carbon neutrality, because I believe that it was just a ploy to sell technology. When I read part 1, I knew about, I think, 3 or 4 of his products for BASF. So I couldn't find that basic definition. But when I went to the Portland Cement Association, they have this really nice roadmap for PCA roadmap to carbon neutrality. And at the back end of it, they have a glossary of terms, like, holy moly guacamole, how awesome is this? And there is a definition for carbon neutrality. And I guess, let me read the definition first. The principle by which CO2 emissions resulting from a product or process are offset either by direct CO2 emission reductions or through avoided CO2 emissions. I like that definition. It's a very, very generic definition, and it doesn't pigeonhole us. The unfortunate reality, when we start talking about concrete carbon neutrality, we're not, and this is my opinion, we're not talking about just the job site. We're not talking about cradle to gate. Mm-hmm. We're talking, is there something before cradle? Before cradle to grave. Mm-hmm. We have material acquisition. And I'm sorry to say, but the material acquisition starts way before cement production. Because we have to get the raw materials for cement production. And then grave is not just breaking down the structure and removing it from site. Grave is also not landfilling it on day one. Grave is the legacy embodied CO2 footprint that we get either from landfilled waste or, when you say landfilled, the assumption is it's put into an engineered landfill, right? So there's that CO2 embodied footprint. But then you also have the folks who just throw it on the side of the road and bury it. So, and that includes state municipalities, as well as the federal side too. Because everybody does just concrete. It's kind of like Mother Nature making a rock, but we did it instead. And that's just not true. So the problem comes with, in my opinion, is we don't have a set definition. And this is why P2P didn't last. We didn't have a set definition. We didn't have a rubric saying, okay, this was prescriptive, this was performance, and this is the level playing field that everybody has. Here are the rules. Go for it. We tried, but we failed miserably. And the same thing with carbon negative. Seth, you've been making concrete for a little bit. If you accept my definition of it, it includes the time before we make the cement and the time after we toss the concrete. How do we actually make concrete that's carbon negative?
Not sure. But I think if you're going to look at concrete that way, then you got to look at all the building materials that way that's being compared to, right?
I'm cool
with that. That's what you're getting at.
Well, I listen, I want to level the playing field, but I don't think we need to do that with all the materials. Like wooden bridges. You can't look at wooden bridges, service life-wise, the same thing, like to replace concrete bridges. You could do that with steel, and as it turns out, galvanized steel, they last longer than concrete bridges. And those aren't my words. I believe that's University of Wisconsin, and that was through a FHWA project. Mm-hmm. So I don't know if we can put all of the materials in the same boat, but if we're asking our ready-mix producers to create a carbon-negative concrete, that what you ship me is a carbon, we can't just tell them, well, use this one admixture. It's not fair. It's not fair to do. And instead of, it's like, was it last year, I can't remember, it was MEGPEC or Colorado DOT started forcing ready-mix providers to use surface resistivity as one of the hardened properties to dictate durability of concrete. And as it turns out, it's I don't know if you've ever done surface resistivity. It's a gun-looking thing. You put it on your cylinder and beepity-beep-boop-bop. You get a value. And the ready-mix providers started using it. And what they found was that depending who did the test, where they did it, the condition of the sample, they would get values all over the place. And even when they use the prescribed back-of-the-soup can standard operating procedures for these different types of samples, there was inconsistencies everywhere. And this has only been a year right now, but what we found is most ready mix providers are not using that method, and they're just not going after that DOT work. Now, it was a great method on paper, and this discussion about making a carbon negative concrete and a concrete that's net zero, all of this is really sound so good. But when it comes to the ready mix provider, and Rich Seishi is a great person to ask when you ask him, is anybody buying carbon negative concrete? And he'll tell you no. Nobody's buying that. People are buying, get me off my job site faster, and how can I do the job with less trained people or just less people? And oh, can you make it cheaper? That's the other thing that people ask for. But they're not buying carbon neutrality. They're not buying carbon negative. And I know there's some ready mix providers, the top 20% are using these new admixtures, but there's an incentivized program for them to do that. Most of the contractors, the 80% that we see, are not buying. I'd love them to. I think that's what most people don't understand. Like, shoot, the easiest way for people to be carbon negative on a job site, this was not my idea, so I cannot take credit for this. And this is why I want you to interview Matt on your own. Matt said, he goes, that if people were really serious about making their job site negative or making their concrete negative, the fastest way of doing that is the salesperson calling up and making sure everybody was ready. How simple is that? How simple is that? And all of a sudden, we have saved so many trucks. Just doing that. To me, carbon neutrality and carbon negative, or that negative endeavor, doesn't come out of materials. It comes out of our methods. And going by our methods, it's a lot cheaper. We don't have to install equipment. It's faster. And, I mean, it's easier, too. What do you mean? All I got to do is tell my salespeople to make sure everybody's ready on the job site and I can reduce the amount of trucks that I'm throwing away? Heck yeah, you can. It's that easy. So, I'm almost at a fed up point because I see this carbon negative, carbon neutral, net zero being used as a way to sell products.
Yeah. Can you back up to that P2P? You were telling me before we hit record a little bit about that. So. Can you tell us what P2P is, and then where it ended up? Obviously it lost legs. So why did it lose legs? So tell us what it is and why we're not hearing that anymore.
Sure. P2P was an endeavor that was kicked off by the concrete industry back in 2006, 2007 timeframe. And the ultimate endeavor of it was to go from a prescriptive base mix, you need a certain amount of this, that, the other, you can't use more than this, to you just need to reach these performance milestones or these properties, fresh and hardened. And again, as I was saying, where I met Rich Seishi was a HPC convention in Dallas, Texas. I believe it was 2007, where he was talking about fast track pavements and high early strength mixes. It was a high performance concrete convention, but he was referring about the BS that comes with high volume class F mixes, and people were getting 3,500 psi in 8 to 12 hours, and they were using 50% class F fly ash. And I'm paraphrasing the story, and I apologize if I get any of the minutia wrong, and I hope you can talk to Rich about this. But Rich was basically calling people out on, this P2P turned into this race to get more and more fly ash, 20%, 30%, 40%, 50% class F fly ash, and we're still achieving these high early strengths. And when I met Rich, he was like, that's BS. 50% F ash, you're not going to get 3,500 in 8 hours unless we look at the minutia, at the details. And what I was talking about, the ready mix company I was working with at the time, they were doing the same thing that Rich was talking about these folks were doing, which is they were, increasing the powder content. At that time, we weren't paying $80 to $120 a ton for Class F fly ash and more for slag. So it had turned this endeavor into how much more fly ash can we get to while we're still achieving these fresh and hardened properties. And it came to a point where I was working for a major ready-mix company at the time, and one of our entire regional divisions were fired. Somebody in there, one of the head of our companies, and I'm trying not to use name, who was the VP GM, went into this regional division, and I was standing behind him like, you're fired, you're fired, you're fired, because that entire region, that division, was condoning the use of these high volume or high powder content mixes to achieve this high volume fly ash, this new performance that we're getting. And they were getting 8,000 PSI, 28 days, and we're all like, how the hell are they doing it? Until we started looking at the minutia, until we started looking at the details. One of the things that I'm doing now is I'm putting on a presentation at ACI that's talking about the 3D printing, and that's one of my other favorite subjects, and I'm not trying to get into that right now, but 3D printing is basically going through a technology transfer. And what I have here is a presentation that I borrowed from Rich. And in the presentation, what I took from Rich was something called the hype curve. Have you ever heard of the hype curve, Seth?
Well, I have, because I've sat in other things that you've done, so I'm cheating.
You're cheating. So the hype curve was developed in 2002 by somebody at Wired magazine. And I hope I can share my screen because I want to show it. What I did is Rich's presentation showed this hype curve for P2P. And in that hype curve, you could see what Rich showed is that, and unfortunately it's not showing up, P2P died somewhere between the peak of inflated expectations and the trough of disillusionment, right? So I don't know how to wear glasses, I guess. When you go through a new technology, there's what is it? There's 5 different phases. There's the technology trigger, the peak of inflated expectations, the trough of disillusionment, the slope of enlightenment, and the plateau of productivity. And the iPhone, for instance, it went through all of those in a very short time period. Like, we got this iPhone. It was the coolest thing in the world. We're attached to everybody in the universe. We can see videos. It's great. All these expectations. It's the best thing since sliced cheese. Then all of a sudden, you can't hold it like this because it blocks the antenna. Trough of disillusionment, right? It just drops, right? Nobody wants to. We need to get those Nextel phones where I could be under 50 feet of earth and still get a signal. But then Apple came out with these amazing fixes, and all of a sudden we're getting into the slope of enlightenment in iPhones and how they're going to change the world until we got to this plateau of productivity where the iPhone or the smartphone, whichever company you want to use, is selling these things and they can't stop, right? The plateau of productivity. P2P died somewhere well before that. And we could say the same thing for SCC. Did I just say that? Self-consolidating concrete has not reached a plateau of productivity? Dude, you were part of the SCC movement. I was part. You remember that movie Lafarge did? They had a...
No, I don't.
Oh, you got to look this up. I keep telling people about this. I've got to find it. Lafarge had this job site. It was in Calgary or Alberta, where they had 2 40-foot by 40-foot concrete slabs that were sitting on a level base. I want to say they were 4 inches, 5 inches thick, right? Just the formwork. Right? I believe there was no mesh in there. It was just open formwork for a slab. 2 teams with 2 trucks, right? The first team was a bunch of dudes, freaking guns blazing. I think it was like 5 or 6 dudes working with conventional concrete. 3 to 5 inch slump coming out of the back of the truck that had rakes, they had pole bars, they had screeds, and bull floats. Second team was this 4'8", skinny female secretary. She showed up to the job site in high heels. Can't make this up. She must have weighed 95 pounds. Showed up to the job site in high heels. She had to take off her high heels. And this is while the guys are already going. Had to take off the high heels, put on muckers, right? And then she gets in, and all of a sudden this SCC comes down the chute. You had one guy on the chute, moving the chute back and forth. She stands in there with that SCC bar. I forgot what it was called. The PVC pipe. And she does that wave motion, walks backwards, then comes back in the air. She finishes that slab in, I want to say, like 10 minutes.
Wow.
It took the team of 5 guys 45 minutes, an hour, considerably longer. Now, as an investor, when I watch that movie, because I still watch it from time to time, I'm like, holy shit, man. This should have taken the industry by storm. But we don't see SCCs. We don't see it in foundations. We don't see it in slabs. We don't see it in walls. We just don't see it. Maybe there's 5%, 10% of the industry that uses it for very special applications. But SCC, it died somewhere in the trough of disillusionment. And what happens with the trough of disillusionment, the technology gets out to the industry, and the industry either likes it, figures out the problems, and it gets out of that disillusionment into that plateau of productivity, or it dies there. Now, SCCs might have died. Oh, John, but some other industries... Okay, on a large scale it died. On a negligible scale that we don't give a shit about, it succeeded. But high-range water reducers and using the shit out of chemistry and concrete that came out of that trough of disillusionment and succeeded through the enlightenment to the productivity. Because we used the hell out of high-range water reducers, poly and otherwise, new accelerators, hydration stabilizers, set accelerators, air types. So the innovation, what really came out of that SCC was educating the industry that there were so many awesome technologies out there, because using SCC, we also had to use all of those to include viscosity modifiers, xanthan gums, dextroses, colloidal silicas. There were just so many technologies that came out of that movement, so that from the death of SCC, the phoenix that rose out of that to that plateau of productivity was the chemical movement and the chemical admixture movement in the concrete industry, which I think all of us can agree has definitely gone out of the trough of disillusionment, out of enlightenment, and into productivity.
Yeah.
I don't
you see that on everyday jobs, pretty much. It's a foregone conclusion that you're going to use some kind of admixture on a job. So,
I want to.
So what you're saying is, out of all this effort for concrete that's carbon neutral or carbon negative, maybe we're going to pull some kind of technology out of it that we can use every day, but maybe not.
I hope it's
maybe it won't have the end result that people are looking for. We're going to get some other things out of it.
I hope I'm wrong, man. I hope somebody gets to look back on this video and the countless other videos that I've done where I'm pissing on Cheerios. I hope somebody... See? You were wrong, Belkowitz. I hope I'm wrong. But right now, what I see with the carbon negative movement is people selling products. Oh, use this product to reduce your carbon negative footprint about concrete. It's not what are the methods. It's not what can everybody do to reduce the carbon negative footprint of concrete. I really see this as, and like I said, all the way through ACI, through the different customers or companies out there that are selling products, everybody has got a new carbon negative concrete product. Just like everybody had a new SCC concrete product. Man, I hope it doesn't crash and burn. I hope it evolves. But based on history, RCC did the same thing. Pervious concrete did the same thing. Right? Concrete maturity. Like, these are all technologies that, yeah, they've succeeded a little, but they're not in the 80% of concrete that's going to make a difference. And very simple ways to be carbon negative on your next job site. I hope that we embrace those ways. I hope this gets out of the trough of disillusionment. But as you can tell, I'm cautiously optimistic.
Yeah, and that's fine. But I think that's a good place for us to stop today, John. What ways can we reach out to you if folks want to learn more about you and Intelligent Concrete?
We've got a great website that we're constantly working on, intelligent-concrete.com. I would say the best place is our LinkedIn channels. From our LinkedIn channels, whether it's Intelligent, mine, or Whitney's, Matt's, Aaliyah's, Harry's, or Paul's, we've got a lot of great resources. And then our YouTube channel, we have somewhere around 780 videos on our YouTube channel. We've got 60 papers published, 60, 50, somewhere around there. So we've got a lot of great resources. And if you want to call me, my number is 719-367-8092. I don't care what we talk about when it comes to concrete. I won't pick up the phone on a Sunday, but 6 days out of the week, I sleep for about 6 hours a day. So if you want to talk about concrete, John, Jon, at intelligent-concrete.com. Reach out to me. I love talking about concrete. Really do.
Yeah. I hope it's very obvious from this recording. So, but thanks, John, for doing this. And we'll have to do it again.
Amen. Likewise.
All right. Thank you for joining us for another Concrete Logic podcast episode. If you got some value out of this or you enjoyed it, please share it with others. And if you could take a moment and give us a 5-star review on your favorite podcast listening app, I would appreciate it. We will catch you on the next episode. And now Mike Dunton's going to take us out. Thanks.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9-to-5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done with wood.